There are moments when the universe does not roar. Moments when the sky does not tear itself apart in spectacle. When nothing explodes across the headlines of our awareness, when no catastrophe announces itself with the urgency we have been trained to recognize. And yet, in those quiet margins, in the spaces between our measurements, in the dark folds of attention where light bends and data accumulates like snowfall in silence, everything shifts. This is one of those moments. Somewhere in the outer darkness of our solar system, far beyond the warm glow of familiar planets, far beyond the asteroid belt we've learned to chart and catalog with confidence, an object drifts. It moves through space with a patience that defies human comprehension, already strange by definition, already marked with a designation that carries the weight of the impossible, the weight of distance so vast it makes our planetary orbits feel like the space between heartbeats. 3I/Atlas. The third confirmed visitor from interstellar space. Not the first, we have seen others, but rare enough that each one rewrites what we thought we understood about the galaxy's hidden architecture. This is a body not born under our sun. Not shaped by the gravitational choreography of our planets. Not trained in the familiar rhythms of our cosmic neighborhood. Not sculpted by the same stellar wind that carved the features of everything we've ever called home. It should have been predictable. It should have passed through our system clean and understood, just another traveler on an ancient trajectory, another line in the ever-growing catalog of things we've learned to measure and then ignore. But it didn't. Somewhere between observation and expectation, somewhere in the accumulation of nights and data points and careful measurements, something changed. Not in the images that capture public wonder, no dramatic flare, no sudden brightening, no tail streaming across the sky in defiance of physics, but in the data streams where astronomers live, where numbers bend in ways they shouldn't, where curves soften when they should remain rigid, where assumptions begin to loosen like old rope under weight it was never meant to carry. Tonight we are not asking what this object is. That question, though tempting, would be premature. Tonight we are asking something simpler, something that carries far more weight than any answer could bear. Why is it changing now? What does it mean when something that crossed unimaginable distances without incident, that survived the crushing cold of interstellar space for millions or perhaps billions of years, that passed through radiation fields and gravitational eddies we can only model from a distance? What does it mean when such an object begins to behave differently only after it enters our neighborhood? Only after it falls under the gaze of our sun? And why does the timing feel uncomfortably precise, as if the universe itself waited, patient and indifferent, for us to be watching before allowing something new to unfold? As if reality knew we were paying attention, and only then decided to reveal a secret it had been holding since before our species learned to look up. When 3I/Atlas was first identified, captured in the automated surveys that sweep the sky each night searching for motion against the fixed background of stars, the label came with implications heavy enough to slow your breathing if you let yourself think about them too long. Interstellar. A traveler from stellar systems we will never see, shaped by stars whose light may have already faded into memory, born in molecular clouds that collapsed under their own weight in epochs when our own sun was perhaps younger, perhaps not yet born at all. For a brief window after its discovery, that rarity seemed destined to become routine, to slip into the comfortable category of understood phenomena. After all, once you calculate an orbit with sufficient precision, once velocity and trajectory are pinned down with mathematical certainty refined over centuries of observation and adjustment, an object becomes predictable. It loses its teeth. It becomes safe. Most visitors follow this script. They arrive, they obey Newton's laws with comforting precision, they pass, they leave, they fade into the catalog of things we no longer need to think about. And for a while, for weeks that stretched into months, 3I/Atlas seemed ready to follow that gentle script. Its brightness held steady across countless nights of observation, measured by telescopes scattered across the planet, each one confirming what the others saw. Its motion traced smooth, Newtonian arcs through the sky, obeying gravity with the kind of precision that makes astronomers smile and relax. Its silence was almost reassuring, a quiet reminder that not everything from the dark needs to be mysterious, that not every visitor from the void carries secrets that resist explanation. But predictability in astronomy is fragile. It is a thin membrane stretched over the unknown. It survives only as long as objects continue to obey, only as long as measurements continue to match predictions, only as long as the universe cooperates with our models of how it should behave. And somewhere in the steady accumulation of measurements, in the nightly ritual of tracking this wanderer across the sky, in the patient work of astronomers who know that truth reveals itself slowly, they noticed something that wouldn't go away. A deviation. Small enough to dismiss at first. Measurement error, atmospheric distortion, instrumental drift. But persistent enough to worry later. The object was not quite following the script anymore. Not dramatically. No sudden swerves that would trigger alarms. No impossible accelerations that would shatter our understanding of physics. But subtly. Stubbornly. Quietly. As if responding to forces no one had accounted for in the initial models. The kind of deviation that doesn't vanish when you average it out across multiple observations. The kind that grows more certain, not less, as data accumulates. The kind that makes you wonder, late at night when the telescope hums and the sky is clear and you're alone with the numbers, if the object is revealing properties you never thought to ask about in the first place. Properties that were always there, hidden, waiting for the right conditions to become visible. Orbital mechanics are built on trust. On the bedrock assumption that gravity is reliable, that motion obeys equations refined over centuries of careful observation, adjusted through the patient, methodical work of astronomers who had to believe, that the sky could be tamed with enough precision, enough data, enough mathematical rigor. When an object enters the solar system, when it crosses that invisible boundary where the sun's influence becomes measurable, we fit its path with extraordinary confidence. We calculate where it has been. We predict where it will go. The curve of its future becomes almost intimate, as if the cosmos itself has confessed its intentions, as if space has opened its ledger and allowed us to read the next chapter before it unfolds. But 3I/Atlas began to resist that intimacy. Its orbital solution still worked, technically, mathematically, on paper, but only after being adjusted. Again and again. Residuals appeared in the data like cracks spreading through ice. Tiny differences between where the object should be according to gravity alone and where it actually was when telescopes found it against the background of stars. At first, these residuals were treated as noise, as the inevitable imperfections that creep into any measurement system. Atmospheric turbulence bending starlight in unpredictable ways. Instrument drift as metal expands and contracts with temperature. Timing errors that accumulate like dust in the corners of a room, small but persistent. Astronomers know these ghosts well. They have learned over generations how to account for them, how to filter them out, how to ignore them. But the deviations return night after night, quiet and stubborn, refusing to be averaged away into the comfort of statistical insignificance. The path still made sense, gravity still held, physics still worked, but it required extra explanation now. Something was nudging the object, ever so slightly, in ways that pure gravitational attraction could not account for. Not enough to break the fundamental rules. Not enough to rewrite textbooks. But enough to suggest an additional influence, a hidden variable, a force acting in ways that did not fit the clean narrative of an inert body falling through space under gravity's patient pull. And in astronomy, the moment you need to add an unseen influence to make the numbers work is the moment the story deepens. Because unseen influences live at the boundary where physics meets mystery, where explanation meets speculation, where understanding gives way to questions that have no immediate answers. And mystery, true mystery, the kind that persists even after careful analysis, is where attention sharpens rather than fades, where curiosity becomes something closer to obsession. One of the oldest explanations for orbital deviation, refined over decades of studying comets and asteroids, is activity. Comets breathe after all. As they warm under the sun's relentless gaze, as solar radiation penetrates their frozen surfaces and heats material that has remained dormant for eons, ice turns to gas in a process as inevitable as sunrise. Gas escapes into space, carrying momentum with it, and that momentum shifts the object's trajectory, gently, measurably, predictably. Astronomers have modeled this dance for generations. They know its rhythms. They know its signatures. They can predict, with remarkable accuracy, how an active comet will deviate from a purely gravitational orbit based on the rate of outgassing and the orientation of the jets. The problem with 3I/Atlas is that it does not look like it's breathing. There is no obvious tail stretching behind it like a luminous banner announcing its passage. No glowing coma swelling into view as volatile material boils away and reflects sunlight back toward our telescopes. No dramatic shedding of dust that would catch the sun's light and reveal itself in images taken night after night. And yet, the motion, The quiet, persistent deviations in its orbit that refuse to disappear no matter how carefully the data is analyzed, suggests a push consistent with outgassing, consistent with material escaping from the surface and carrying momentum away into space. A contradiction emerges, uncomfortable and undeniable, refusing to resolve itself into clarity. How can something behave like an active body, showing all the orbital signatures of a comet venting gas into space, while simultaneously looking inert, showing none of the visual signatures that should accompany such activity? Astronomers return to their models, testing and retesting scenarios of weak activity, of gas release without accompanying dust, of venting too subtle to photograph at current distances but strong enough to alter the trajectory in measurable ways. But each explanation, no matter how carefully constructed, left behind a remainder, a residue of discomfort that wouldn't dissolve. Why now? Why does this behavior begin after so much interstellar travel without incident, after millions or billions of years drifting through the void without showing any signs of activity? Did something change within the object itself? A crack opening under thermal stress, pressure building and releasing, some internal transition triggered by warming? Or did the environment change around it in ways that made dormant processes suddenly visible? The sun's influence grows stronger with proximity after all. Radiation pressure increases as distance decreases, following an inverse square law that makes closeness matter exponentially. Thermal gradients deepen as one side faces the sun while the other remains in shadow, creating stresses that frozen material has never experienced before. Solar wind presses against surfaces that have known only the emptiness of interstellar space, only the occasional passage through diffuse molecular clouds, for longer than human civilization has existed. Perhaps the object is not changing at all. Perhaps it is simply responding to a test it has never faced before, revealing properties that were always there but remain dormant until conditions align to make them visible. Perhaps what we're seeing is not a change but an unveiling. Brightness is a language, subtle and rich with information for those who know how to read it. As an object tumbles through space, rotating on one or more axes depending on how it was set spinning by whatever event launched it into the void, different surfaces catch sunlight and reflect it back toward Earth. This creates rhythms in brightness, what astronomers call light curves, that reveal shape, texture, surface properties, rotation period. For a simple, uniform sphere, the light curve would be flat, unchanging. For an irregular object, a tumbling fragment of rock shaped by ancient collisions, the light curve becomes a signature, a fingerprint written in photons. For 3I/Atlas, those rhythms began to complicate in ways that defied simple interpretation. Not wildly, no sudden flares that would suggest explosive events, no dramatic dimming that would indicate something passing in front of the object, but enough to suggest complexity beneath the surface, complexity that resisted reduction to simple models. The light curve hinted at irregularity, at a shape not easily reduced to the clean geometry of spheres or ellipsoids, or perhaps at a rotation state more chaotic than the simple spin most objects settle into over time. Tumbling objects exist, of course. Contact binaries, two bodies barely held together by gravity so weak that they touch but do not merge, exist. We've seen them before in our own asteroid belt, understood them, cataloged them. But interstellar visitors with such behavior remain rare enough to raise eyebrows, to prompt conversations in hallways after seminars, to generate emails between researchers who wonder if they're seeing something truly unusual or simply misinterpreting familiar phenomena. The question emerged quietly at first, whispered in the margins of conference presentations, then louder as more data accumulated. Is this object structurally simple, just an oddly shaped rock tumbling through space? Or is it internally layered, fractured by ancient impacts or thermal stress, responding dynamically to forces we cannot see directly? And deeper still, pushing beneath the surface questions into territory where speculation becomes necessary, are we witnessing a process that only becomes visible under solar influence? Light, after all, does not just illuminate. It interrogates. It forces surfaces to confess their nature, to reveal albedo and composition and texture through the way photons bounce and scatter. And what it reveals here is not clarity, not a clean answer we can file away with confidence, but texture, a body that seems unwilling or perhaps unable to tell a single, clean story. A visitor that becomes more mysterious the longer we watch it. Spectroscopy allows astronomers to taste light, to break it apart into its constituent wavelengths, to separate the blended whole into fingerprints of composition as unique as the chemical autobiography written into every photon that reaches us from the void. In the case of 3I/Atlas, those fingerprints refused to line up neatly into familiar patterns. There were hints of carbon-rich material, organic molecules perhaps, traces suggesting surfaces darkened by radiation over immense spans of time, scoured by cosmic rays until the original brightness faded into something closer to charcoal than ice. And yet, alongside those signatures of age, there existed an absence, a conspicuous, troubling absence, of the strong volatile signatures you would expect from an object now showing dynamic behavior consistent with outgassing. It was as if the surface had been baked and weathered by eons of cosmic exposure, by radiation fields between stars that dwarf anything we experience in our protected corner of the galaxy, scoured until it became something hardened and silent and seemingly dead, while the interior remained capable of response, still holding volatile materials that could escape under the right conditions. This duality, ancient outside, reactive inside, raised uncomfortable questions that wouldn't stay buried no matter how carefully researchers phrased their papers. How long has this object been traveling? Not thousands of years. Not millions. Perhaps hundreds of millions. Perhaps longer. What environments has it passed through during that unimaginable journey? What stars did it pass close enough to feel their warmth? What molecular clouds did it drift through, collecting dust like a ship gathering barnacles? Cosmic rays scar surfaces over millions of years, etching their presence into every exposed grain, creating layers of radiation damage that serve as crude clocks measuring exposure to the interstellar environment. Yet internal ice, volatile compounds that would boil away quickly under direct sunlight, can survive beneath protective layers of that radiation-darkened crust, shielded and waiting, unchanged and patient. If that's true here, if 3I/Atlas is indeed such a layered body carrying both ancient crust and pristine interior, then what we're witnessing may not be a sudden change at all, but a delayed reaction. A memory of formation awakening only now, triggered by conditions it hasn't encountered since it was born under a different star, in a different system, in an epoch so distant it makes human history feel like a brief flicker. And that idea alone reshapes the narrative from simple curiosity into something deeper, something that touches on time scales and patience that human minds struggle to grasp. The realization that objects can carry histories so long, so patient, that they only become readable when conditions align just right, when the universe conspires to make the invisible visible. Astronomy often relies on absence as much as presence, on what is missing as much as what is found. The shadow speaks as loudly as the light, sometimes louder if you know how to listen. And here, in the story of 3I/Atlas, absence became impossible to ignore, growing louder with every observation that failed to find what should be there, what experience and theory both insisted must accompany the behavior we were seeing. Where is the dust? Where is the tail? Where is the spectacle? If gas is escaping from the surface, if the object is venting material into space with enough force to alter its orbit measurably, why does it not drag particles with it? Why don't we see the classic signatures of cometary activity that every textbook describes? The glowing halo of gas surrounding the nucleus, the elongated tail of dust particles pushed back by solar wind and radiation pressure, the debris trail marking the object's passage like breadcrumbs through space. One possibility is mass. Heavy particles, dust grains and larger fragments, fall back under the object's weak gravity before they can escape into space, creating a cycle of ejection and reaccumulation that leaves no visible trail. Another possibility is composition. Perhaps the escaping volatiles don't condense into visible dust at all, slipping away as pure gas that reflects no sunlight, invisible to our telescopes no matter how carefully we look. Another is geometry. Maybe jets are aimed away from our line of sight, venting into space at angles we cannot observe from Earth's position, creating thrust we can measure through orbital changes but cannot photograph directly. Each explanation works individually. Each one fits some aspect of the data. Together, they form not a solution but a maze, a tangle of possibilities that fit the observations but refuse to settle into certainty, refuse to collapse into a single clear narrative we can accept with confidence. The object continues to behave as if something is happening, as if active processes are unfolding on or within it, while simultaneously refusing to show us clearly, unambiguously, what that something is. And that refusal becomes a hook that sinks deeper the longer we watch, the more data we gather, the more nights we spend pointing telescopes at this strange visitor and collecting photons that raise more questions than they answer. Because when nature withholds clarity, when the universe presents us with behavior that fits multiple explanations equally well, it's often not hiding secrets deliberately, it's simply indifferent to our expectations, proceeding according to rules we haven't fully learned yet. Yet that indifference, when encountered by human curiosity, by minds evolved to seek patterns and causes, feels uncomfortably personal. It feels like the universe is teasing us, showing just enough to make us wonder while withholding just enough to prevent certainty. Calling 3i/Atlas a messenger doesn't mean it was sent. Doesn't imply intention or purpose or design. It means it carries information simply by existing, by being what it is and doing what it does, by moving through space in ways we can measure and analyze. Its trajectory tells a story of ejection from another system, flung into the void by gravitational interactions we can only model from a distance, perhaps during planetary migration or stellar encounters that sent debris scattering like sparks from a fire. Its composition tells a story of formation under a different star, in conditions that may have been nothing like the molecular cloud that collapsed to birth our own sun and planets, perhaps richer in certain elements, perhaps poorer in others, perhaps shaped by stellar winds and radiation environments utterly unlike what we know. Its behavior now, here in our system, tells a story of interaction with a new environment, of responses triggered by solar radiation and warmth after eons of cold so deep it defies imagination. Interstellar objects are archives without authors. They are pages torn from books we never saw written, drifting through space with no memory of their origins, no awareness of the questions they carry, no understanding of what their existence means to the intelligent species that eventually notices them. When one begins to behave unexpectedly, when it does something that doesn't fit our models cleanly, it is not announcing intelligence. Nothing so dramatic, nothing that would rewrite our understanding of our place in the cosmos. It is simply announcing complexity. And complexity is so often mistaken for intention, especially by minds trained to see patterns and purpose, minds that evolved in an environment where most complex behavior did imply agents acting with goals. The challenge here is to remain grounded while allowing wonder, to resist the leap from unusual to impossible to artificial, while still acknowledging that even the most natural, most mundane explanation carries weight. Because even if this is simply a weakly active interstellar body responding to solar heating in ways we didn't fully anticipate, even if that is the complete story, the full truth with no hidden layers, it has implications that stretch far beyond this single object, far beyond this single observation. It suggests that the galaxy may be filled with such travelers, countless fragments ejected from stellar systems during planet formation or later catastrophes, most of them silent and invisible as they drift through the dark, but some fraction capable of activity when conditions trigger it. And if that's true, if interstellar space is indeed populated with such debris, then our solar system may be less isolated than it feels, less unique than we imagined. We may be drifting through a sea of material far richer and stranger than our early naive models suggested, a galaxy filled with stories written in rock and ice, waiting only for the right conditions to become readable. Why now? This question threads through every analysis, every model iteration, every late-night conversation between researchers who can't quite let the mystery rest. 3i/Atlas traveled through interstellar space for millions of years at minimum, perhaps billions if its velocity and trajectory suggest a truly ancient origin. It passed other stars during that journey, some close enough to feel their warmth, others distant points of light barely distinguishable from the cosmic background. It bathed in their radiation. It endured temperatures so low they defy human intuition, cold that would freeze air itself into crystals, cold so profound that molecular motion nearly stops, where only quantum effects prevent complete stillness. And yet its unusual behavior emerges only here, only now, only under the influence of our sun, after crossing unimaginable distances without showing any signs of the activity we're now detecting. Timing in astronomy is rarely coincidental, but it is often misunderstood, often more subtle than dramatic narratives suggest. The sun provides a unique environment, not just light and warmth, though those matter, but sustained radiation of specific wavelengths, thermal cycling as the object rotates and different surfaces face toward and away from the star, gravitational tides that grow stronger with proximity, solar wind pressing against surfaces with relentless patience, day after day after day. Perhaps this is the first time the object has experienced such prolonged stress since it was ejected from its birth system eons ago, the first time it has been subjected to sustained heating and illumination strong enough to trigger processes that remain dormant during its long journey through the dark. Or perhaps, and this possibility unsettles in a different way, the behavior existed before, unnoticed and unrecorded because no one was watching closely enough, because it passed through other systems without intelligent observers, or passed through at times when those observers weren't looking at the right part of the sky with instruments sensitive enough to detect subtle changes. Both possibilities unsettle in different ways, carry different implications that ripple outward. One suggests the sun is actively revealing secrets, that our star functions as a kind of cosmic interrogator, a laboratory that forces objects passing through to confess their hidden properties, to reveal aspects of their nature that remain dormant in the cold and dark between stars. The other suggests we are only just beginning to see what has always been happening, that our tools and attention and network of observers have finally caught up to a reality that was always there, always unfolding, just beyond the threshold of our awareness. Neither option offers comfort. Neither allows us to relax into certainty. Both widen the questions we'll carry forward, expand the space of possibilities we must consider. As data accumulated week by week, as observations piled up from telescopes scattered across the planet and in orbit above the atmosphere, models had to stretch to accommodate it all, had to become more complex, more nuanced, less clean. Astronomers adjusted parameters one by one, adding weak non-gravitational terms to their equations to account for forces beyond pure gravity, testing assumptions about mass and shape and thermal conductivity and surface composition, running simulations that tried to reproduce the observed behavior by tweaking variables within reasonable ranges. Most of the time, in most cases, models win these battles. They absorb anomalies. They smooth over rough edges. They incorporate new data and restore calm, providing explanations that satisfy both the mathematics and the intuition, allowing astronomers to close the case and move on to the next mystery. But here, with 3i/Atlas, the calm didn't fully return. Each adjustment improved the fit between prediction and observation, narrowed the error bars, reduced the residuals, made the numbers line up more cleanly, but left behind questions that wouldn't dissolve no matter how carefully the models were refined. Why does this object require so much explanation for such small deviations? Why does it behave like a comet without looking like one? Why does its interstellar origin matter so much more now than it did at discovery, when it was just another dot moving against the background stars, interesting primarily for its velocity and trajectory? The discomfort wasn't that models failed. They didn't, not really, not in any fundamental sense that would require throwing out established physics. The discomfort was that they succeeded too imperfectly. They explained just enough to keep the mystery alive, to hold it in suspension without letting it collapse into certainty. And that state, hovering between known and unknown, between explanation and mystery, is where science often lives longest, where the most interesting work gets done, where understanding deepens not through sudden breakthroughs but through patient accumulation of evidence that slowly reshapes intuition. The most responsible conclusion, the one that appears in careful journal papers written by researchers who know how easily speculation can outpace evidence, remains the least dramatic. 3i/Atlas is a natural object exhibiting weak activity under solar influence. No artificial structures. No hidden purpose. No intelligence guiding its behavior. Just physics, just chemistry, just natural processes responding to environment in ways we're still learning to understand fully. And yet, even this conclusion, even this mundane, scientifically conservative explanation, carries weight that settles slowly, that changes the landscape of what we thought we knew. It implies that interstellar debris is not inert, not dead, not finished evolving. That it can change, respond, exhibit behavior even after eons of apparent stillness, even after crossing distances so vast they make our solar system feel claustrophobic by comparison. That the boundary between dead rock and active body is thinner and more permeable than we assumed, less a sharp division and more a spectrum with complex dependencies on composition and environment and history. It implies that our solar system is not merely a passive recipient of visitors, a safe harbor where objects drift through unchanged like leaves floating past on a stream. It is an active laboratory, a testing ground, a place that transforms what enters it, subtly but measurably, revealing properties that remained hidden in the dark. And if that's true, if every interstellar object that passes through may leave differently than it arrived, not just in trajectory but in state, in behavior, in what it reveals about itself, then the implications widen dramatically. Every visitor becomes not just a curiosity but a probe, an experiment conducted by the galaxy itself, testing what happens when material formed in one environment encounters another. That realization doesn't calm the mind. It doesn't provide closure. It widens the stage, expands the cast of possibilities, reminds us how much we still don't know about the space between stars, about the population of objects drifting through that space, about what happens when they encounter stellar systems like ours. As whispers of unusual behavior spread beyond the closed circles of professional astronomy, beyond journal articles and conference presentations and email threads between specialists, public imagination accelerated in ways both predictable and revealing. Speculation leaped ahead of data with the speed that only human curiosity can achieve, filling gaps with wonder and worry in equal measure. Artificial structures, directed motion, hidden purpose. The shadow of other explanations, darker and stranger, stretched across internet forums and news headlines, across conversations in coffee shops and classrooms, across the collective consciousness of a species that has always looked at the sky and wondered what it means. Scientists responded with caution, not dismissal, an important distinction. Because they know better than most that imagination is not the enemy of science. It is science's shadow, its companion, sometimes its fuel. The danger lies not in wondering, not in allowing speculation to explore possibilities beyond what current evidence supports, but in concluding too quickly, in hardening speculation into belief before evidence can catch up, in mistaking could be for must be. Yet the persistence of that speculation, the way it refused to die even as researchers offered increasingly detailed natural explanations, reveals something important about human psychology, about how we relate to mystery. Humans sense that this object matters, even if they cannot articulate precisely why. And that sense of importance is fueled not by what we know, but by what we cannot yet explain cleanly, by the gaps in understanding that leave room for imagination to operate. Mystery is not a flaw in the story. It is not a temporary embarrassment to be eliminated as quickly as possible. It is the engine. It is what keeps people watching the sky, asking questions, waiting for the next data release, checking websites for updates. And perhaps that is the real gift of objects like 3i/Atlas. Not immediate answers, not clean resolutions, but the reminder that there are still questions worth asking, still mysteries worth pursuing, still aspects of reality that resist easy explanation and demand patience. Zoom out far enough, expand your perspective to galactic scales, and 3i/Atlas becomes less unique, less exceptional. The galaxy is not empty. It never was. Stars form planets through accretion in the chaotic disks of gas and dust that surround young stellar systems. Planets scatter material during migration, during the gravitational shuffling that occurs as giant worlds settle into stable orbits, during collisions in the violent early epochs of system formation. Systems interact gravitationally when stars pass close to each other, flinging debris into interstellar space like stones skipped across a cosmic pond, like sparks thrown from grinding wheels. The galaxy fills with fragments, most drifting unseen through the dark, their numbers uncountable, their trajectories uncalculated, a vast population we're only beginning to characterize. A few intersect our path by chance, by the simple statistics of motion in three-dimensional space over billions of years. The fact that one of them is now behaving oddly is less surprising, when viewed from this perspective, than the fact that we ever expected them to be simple. Interstellar space is not empty. It is diluted. Complexity scattered across vast volumes becomes rare in any given cubic kilometer but common across the galaxy as a whole. And diluted complexity still matters. The galaxy may be a slow storm of debris, each piece carrying subtle responses to new environments it encounters, each one a potential teacher if we watch closely enough, if we're patient enough to let it reveal its secrets. In that context, against that background, 3i/Atlas is not an exception. It is not an anomaly demanding special explanation. It is a sample. One data point in a larger population. And samples are dangerous, intellectually dangerous because they invite generalization, they force us to reconsider assumptions we built on smaller datasets and narrower experience, they suggest that what we see in one case may apply to many others we haven't observed yet. Between observations there is silence. No new data arrives. No light curves are updated. No orbital solutions are refined. Telescopes point elsewhere, chasing other targets, other mysteries, following the priority lists compiled by committees and algorithms. And in that silence, which can last hours or days or weeks depending on weather and scheduling and the demands of other science programs, the object continues its journey, utterly indifferent to our attention or lack thereof. Whatever process is unfolding within it or upon it, whatever changes are happening at the molecular or macroscopic scale, does not pause when we stop watching. Reality continues whether observed or not, a philosophical point that feels different when confronting an object that won't hold still in our models. This asymmetry, between continuous reality and intermittent observation, between what is actually happening out there in space and what we manage to capture in our limited observation windows, creates tension that astronomers feel viscerally but rarely speak about outside their own community. We never see the whole story. We never get continuous coverage. We see only frames, snapshots separated by hours or days or weeks, discrete samples of a process that unfolds continuously. And those frames, when assembled into sequence, suggest motion we cannot fully track, changes happening in the gaps between our glances, transitions occurring in the blind spots of our observation network. The idea that something important could happen between observations, something revealing or transformative, unnoticed and unrecorded simply because no telescope happened to be pointed at the right patch of sky at the right time, unsettles astronomers more than the idea of dramatic change. Because dramatic change, at least, announces itself eventually. But subtle change, gradual evolution, processes that unfold slowly over the gaps in our coverage, those can remain invisible indefinitely, shaping reality in ways we never detect. It reminds us how narrow our windows truly are, how much we miss simply by blinking, by being human observers with finite resources and imperfect coverage of an infinite sky. Asteroid, comet, interstellar object. These categories are tools we built, linguistic bins we constructed to organize our understanding, to sort the vast complexity of the solar system into manageable chunks that could fit in textbooks and databases. We built them to help us think, to create boundaries that made analysis easier, made prediction possible, made communication between researchers more efficient. But 3i/Atlas strains them all. It behaves like more than one thing at once, like a hybrid that refuses to settle cleanly into any single definition we've prepared for it. It has properties of an asteroid, solid, no obvious atmosphere, surfaces that seem inactive. It has properties of a comet, orbital behavior suggesting outgassing, subtle forces acting beyond pure gravity. It has properties unique to interstellar objects, composition suggesting formation elsewhere, trajectory originating far beyond the sun's gravitational domain. Perhaps our taxonomy is too rigid. Perhaps the categories we built from studying objects born in our own system don't translate cleanly to visitors from elsewhere. Perhaps the universe does not respect our bins, our neat divisions between types, our assumption that everything must fit somewhere in the classification scheme we've developed. Hybrid objects may be common. Transitional states may dominate. The boundaries we drew may be artifacts of our limited sample, lines we imposed on a continuous spectrum. The realization here is subtle but profound. Classification is a human comfort, not a cosmic law. It serves us, not nature. And when an object resists classification, when it behaves in ways that span multiple categories or fit none of them cleanly, it invites us. No, it demands that we revise our language, not the universe. To expand our categories, to create new bins, to refine our definitions, or perhaps to abandon the idea that everything must fit neatly somewhere, that nature must conform to our organizational schemes. Nature is messier than language. It always has been. It always will be. Every unexpected behavior in the sky, every anomaly that resists easy explanation, reflects something about us as much as about the cosmos. Our assumptions, our blind spots, our cognitive limits. 3i/Atlas is not challenging physics in any fundamental sense. Gravity still works exactly as Einstein described, thermodynamics still holds, conservation laws remain inviolate. It is challenging expectation. It is revealing gaps between what we thought we understood and what reality actually does. It reminds us that we are new to interstellar observation,